Our home planet, Earth, is a small blue dot amid the vast ocean of the cosmos. Everyone you've ever met, every person who has ever lived, and every tale that has ever been told lives here. It's the starting point of our voyage. But as we fly out, past the moon, our atmosphere, the sun, and the well-known planets, we set out on an epic journey to understand the actual size of the cosmos. The moon serves as the first landmark on our cosmic voyage as we depart from Earth's embrace. About 384,400 kilometers away, so far away that it would take more than 160 days to get there if you drove a car at a steady 100 kilometers per hour. And from this lunar perspective, Earth is seen as a delicate ball of green and blue, cradled in the dark emptiness of space, a sight that humbles us. This is the moon's view of Earth. The sun, which is around 1 astronomical unit from Earth, is the next landmark as we continue our trip outward. The conventional unit of measurement for distances in our solar system is this one, which is equal to roughly 150 million kilometers. Consider this. Light travels from the sun to Earth in approximately 8 minutes and 20 seconds, at the incredible speed of 300,000 kilometers per second. It would take almost 19 years to reach this distance in a commercial jet when traveling at 900 kilometers per hour. Even inside our own solar system, this enormous distance serves as a sobering reminder of how vast space is. From this amazing distance, the sun, a flaming giant, gives our planet the energy it needs to survive. We set our sights on Mars, our mysterious red neighbor, as we venture beyond our own planet and its solar companion, the Sun. At its closest point, Mars is roughly 54.6 million kilometers from Earth. However, when the two planets are on different sides of the Sun, this distance might reach 401 million kilometers. To put that into perspective, it would take up to 50 years to fly to Mars at the speed of a commercial jet. One of the biggest obstacles to space exploration has been the enormous distance between Earth and Mars. Because of the ever-changing distances and orbital dynamics, the rovers and probes that we have dispatched to the Red Planet face a trip that is not only lengthy, but also complicated. We come to the far-off ice giant Neptune on our trek to the furthest regions of our solar system. Neptune, which is around 4.5 billion kilometers from Earth, delineates the boundaries of our solar neighborhood. It takes roughly 4 hours and 15 minutes for sunlight to travel from the Sun to Neptune via the void of space. The vastness of our solar system is demonstrated by this astounding distance. The Voyager 1 spacecraft, which was launched in 1977, is a symbol of humanity's unquenchable curiosity and ambition to venture beyond established bounds. Voyager 1 has already been in orbit for more than 40 years, traveling an incredible 22 billion kilometers away from Earth. It is a silent stray in the cosmic sea, and the furthest man-made item from our planet. In 1990, the famous scientist Carl Sagan recommended that Voyager 1 take a last picture with its camera toward Earth. The famous pale blue dot image was the outcome of this. Our planet was a small, dim dot in the expanse of space, around 6 billion kilometers from Earth. In his poetic reflections on this picture, Sagan emphasized the need for us to value and protect our one and only home, a tiny dot in the vast cosmos. The Oort cloud is a huge hypothetical sphere of frozen objects located at the outer edge of our solar system. The estimated distance of this far-off cloud from the Sun is an astounding 100,000 astronomical units. The distance is so great that it is on the verge of interstellar space at roughly 1.9 light-years. The heliopause, the point in interstellar space where the interstellar medium stops the Sun's solar wind, is identified by scientists. This marks the beginning of the vast world of interstellar space and the end of the influence of our Sun. The Oort cloud is the last frontier of our solar system, the area where the cosmic voyage into the galaxy really begins and the Sun's influence diminishes. Alpha Centauri, the nearest star system to our Sun, is the next object of interest as we travel outside the boundaries of our solar system. It is roughly 41.3 trillion kilometers away, or more than 276,000 astronomical units. The AU, a metric that is so useful within our solar system, starts to lose its usefulness at such enormous distances. For interstellar measurements, astronomers use the light year, which is the distance light travels in a year. We are roughly 4.4 light-years away from Alpha Centauri. The idea of traveling to Alpha Centauri is nearly unthinkable, given the state of space travel technology today. For example, it would take more than 70,000 years for the Voyager spacecraft to approach this nearby star system, at a speed of roughly 17 kilometers per second. This enormous distance emphasizes the difficulties of interstellar travel, as well as the size of the space that separates the stars. We now travel to the Milky Way, the vast expanse of our own galaxy. This enormous spiral galaxy, which has a diameter of roughly 100,000 light-years, is home to hundreds of billions of stars, each of which may have its own planetary systems. The human radio bubble is a tiny sphere located within this massive structure that is roughly 100 light-years from Earth. The reach of our television and radio transmissions into space is represented by this bubble, which is the furthest point of human influence in the universe. It seems as though humanity has never existed outside of this bubble, since our signals haven't yet reached the civilizations that inhabit the great majority of our galaxy. They would be unaware of our existence. Our whole recorded history is but a murmur in the cosmic wind, invisible beyond this tiny bubble, due to the Milky Way's immense magnitude. We enter the immense, nearly unfathomable world of intergalactic space as we depart from the Milky Way. Here, galaxies are separated by incredible distances and float on the cosmic ocean. Our galaxy is a member of the Local Group, a small cosmic neighborhood made up of around 50 galaxies, dispersed over about 10 million light-years. In addition to spiral galaxies with thousands of galaxies, from at least 100 galaxy groupings and clusters, each with its own multitude of stars and planets, the Virgo Supercluster is a mammoth structure in the cosmos that spans an area of space around 110 million light-years in diameter, or 33 megaparsecs. The Laniakea Supercluster is a much more amazing cosmic structure that we reach when we go outside from the Virgo Supercluster. Our cosmic home is this vast group of galaxies, which spans more than 500 million light-years and includes the Virgo Supercluster. The name Laniakea, which translates as infinite heaven in Hawaiian, is aptly described. Laniakea, a gravitational masterpiece with a mass of 100 million billion suns, is home to galaxy clusters, superclusters, and innumerable celestial bodies connected by a cosmic web of motion and attraction. The Great Attractor, a mysterious area of space at the center of Laniakea, pulls the galaxies in this supercluster with a tremendous gravitational force. Our Milky Way, the entire Local Group, and even the Virgo Supercluster are minuscule parts of this enormous structure in this immense expanse. Laniakea gives our existence a significant context. We are a part of something much bigger and more magnificent than we can even begin to imagine in this vast supercluster. The limits of the observable universe, an astronomical wonder with a diameter of roughly 93 billion light-years, are encountered when we approach the limits of our cosmic exploration. This raises an intriguing query. How can the universe be so huge if it is just 13.8 billion years old? The nature of cosmic expansion holds the answer. Since the Big Bang, the universe has been growing, extending space and causing the separations between celestial bodies to increase. However, what is outside of the universe that can be observed? This continues to be one of cosmology's biggest mysteries. Some areas of space are permanently disappearing from our vision as they expand away from us faster than light. As a result, the actual size of the universe as a whole is unknown and may be limitless. Despite its vastness, the observable universe may only represent a small portion of the overall cosmic expanse. As they withdraw eternally into the depths of the ever-expanding universe, we are left with the sobering knowledge that there may always be areas of space, entire galaxies, and wonders that we will never see.